Vanilla OS 2 is in beta.
Do you know how do they keep it immutable? Is it just policy, or do they have some extra technology that ensures that the system never gets overwritten except by basically itself? But what happens if you actually do want to make changes to the underlying OS?
Hello, how the tech are you? I am HK Perrin, and I've got a really cool story this week. Vanilla OS 2 is in beta. If you've never heard of Vanilla OS, it is an immutable Linux distro. And what immutable means is you can't write to the system partition. In other words, all of the software that makes your computer run is safely untouchable, and you can add things to it by using what's called an overlay OS. So you can add like your own packages to it, and you can add your own applications on top of it. But the underlying system will always be in a stable state because you can't actually modify it. So version 2 of Vanilla OS has been rebased on Debian instead of Ubuntu. Love to see that. And something notable about Vanilla OS is they focus on virtualization technology. So they actually have a way to install packages from most major distributions. So you can install Debian packages, you can install Fedora packages, you can install Arch packages, all on the same system, and they will run in a container environment to actually let them work, even though the underlying system is based on Debian. Another interesting thing is they use an A-B partition scheme, which means if you're running on A and it's time for an update, partition B will be updated, and then next time you reboot, it'll try to boot from partition B, and if that doesn't work, then it'll go back to A. An update will never break your system. As long as you have a currently working system, an update using that A-B partition scheme won't break your system. It's very reminiscent of how modern Android works. Modern Android also uses that A-B partition scheme, and modern Android is an immutable file system. It always has been. You know, Android has that system partition, which is immutable. But I think Vanilla OS is better because there's no Google at all in it. All right, Matt, what do you think?
That's pretty cool. Yes, as you're saying, it was immutable. I'm like, that would make sense to have VMs on that, and like then like the base system is pretty secure. So I mean, you probably don't know, but do you know how do they keep it immutable? Is it just policy, or do they have some extra technology that ensures that the system never gets overwritten except by basically itself for the AB?
So I knew how they did it with version 1.
Okay.
But I don't know if version 2 is exactly the same. So I'll go over how Vanilla OS 1 works. Basically, you have a file system that's mounted as read-only. That's your root file system. Okay. And if you want to modify that, you can do transactional modifications, meaning you can mount the file system, make changes, and only once you commit those changes does the entire thing sit on top of that underlying immutable file system. And I believe in version 1 they used OS tree. I could be wrong, but basically what that does is you have this underlying file system, and you have a layer on top of that you can make changes to that layer, and it'll look like the whole file system is changing, but all that's happening is like things sitting in between. OS tree is keeping track of like, okay, this file in the underlying file system you deleted, this one you changed, this one you added. So it looks to you like you're modifying the real file system, but the underlying OS is still mounted as a read-only partition. And I believe in Vanilla OS 2, they have changed that. So I don't know how they're doing it now, but you can read more on the blog post announcing this, that they did change to OCI images as their underlying structure. So I believe now the partitions themselves, the A and B partitions, are images that can't be changed. You know, they're immutable file systems even.
Interesting. So I was just wondering, like, it sounds like they have some, it sounds pretty secure, although it's kind of strange to have like something writable on top of it, because then even though you can't actually change the underlying operating system, you kind of get the same effects, at least within whatever like VM you're running or something.
That is true, but the whole benefit to it is that if you do something that ends up breaking your system, you can always remove that layer, and then you're back down to that base image, which you know works.
Right. Yeah.
So it's kind of like a safe mode, if you remember, like Windows safe mode, where it just runs without like drivers and automatically loading programs and all that.
Yeah.
It's similar to that. I mean, not the same, because that's not based on an immutable file system, but it's similar to that.
But what happens if you actually do want to make changes to the underlying OS to?
So I believe if you want to make real changes to the underlying system, you have to create your own OCI image and then install that onto that partition, I believe.
Okay.
Which creating an OCI image isn't that hard.
So
and
is this
still
fairly,
like you're always starting off with a base image that even if you really mess something up, you could always just replace that partition with one of their base images published from their repositories.
So this is a pretty thin like OS layer then. So it's calling out for for more stuff, or running everything in a VM. So you have all your control there pretty much. Or
so one of the nice things is it really keeps applications separated because they're all running in their own containers. So for example, if you're using Node.js in a container, and then in another container you're running Discord can't see what you're doing with Node.js in the other container. Like, it not only can it not access it, it doesn't even know that it exists. To Discord, it is the only thing running on the system. Like, as it looks around the system, it only sees itself, and like the kernel processes and stuff.
Yeah. It probably means if you do have like multiple programs that need to talk to each other, it's a little more complicated.
Yes, it does get more complicated when you actually want things to talk to each other. But that should get better as portals become more of the standard, and Pipewire already supports routing video, but that's going to be another nice thing, is like you can give Pipewire access to everything, and then you can tell Pipewire what should have access to what thing. So like something can't just start recording you without your...
Cool. So I was just making sure, like, you definitely would want it to be a fairly small or thin OS if you're going to do an A/B partition thing like you're talking about, because then you have to have twice of everything. It's gonna be.
So that was one of the major criticisms of their version 1, where each partition was 20 gigabytes. So if you had a 100 gigabyte disk, 40 gigabytes of that disk was just used for system partitions. So you only had 60 gigabytes left to use for all your personal files. And with this new version, they are essentially adding, they're creating they already have implemented a new system that I have no idea how it works, but essentially these file systems become much smaller. So rather than 20 gigabytes each, they're like, I can't remember what it said, something like 8 gigabytes each, or like 5 gigabytes each, something like that. But it's much smaller, and it's much more similar to like a regular operating system installation, where you have like, 6 to 10 gigabytes for the OS and all your apps, and then like, everything else is like your userland apps and personal files.
So do you have a computer that you're gonna try it on, or are you just reporting? I have enough stuff to work on right now.
I am running the Vanilla OS 1 on my, like, this little computer that I have that was like $130. So it's like a really bad computer. And Vanilla OS is actually really nice on that thing. Like, it's a very streamlined operating system. So the reason the name is Vanilla is because they don't make changes to the desktop environment. So when you install Vanilla OS, regular GNOME, there's nothing on top of it. They don't have any GNOME extensions. They don't do any like theming. So you just get regular GNOME with the regular theme, and you can add your own extensions on top of it and your own, themes or whatever you want. Okay. But starting off with that very vanilla experience is really nice. That's a big reason I'm on Fedora, is because Fedora also has a very vanilla experience. It's not perfectly vanilla. They do have, I think, one GNOME extension that is pre-installed, but it's only like to put their logo on the desktop, and you can just turn that off. It doesn't change any of the like functionality of GNOME.
not going to change from Ubuntu anytime soon, but maybe if I get a new computer, I need to try something else. Yeah, that sounds cool.
Thank you for tuning in to How the Tech Are You? We do the show every week, and we put it out in several segments on YouTube. And we also have a podcast that you can find on our website, echoplexmedia.com, where you can also support us. Don't forget to like and subscribe, and we'll have another video for you up on the screen right now.